Hi there, Mr Miah here, and welcome to this tutorial where we will be going over simplifying algebraic fractions. So I want you to consider 10 over 15 and how we would simplify this. Well, we would find common factors of 10 and 15, which in this case is 5, and we would just do 10 divided by 5, or how many times does 5 go into 10, which is twice. How many times does 5 go into 15? The answer is 3. We can apply that sort of logic with algebra and simplifying fractions, where we need to find common factors of the numerator and common factors of the denominator and cancel them down. So if you take the numerator, which is x squared plus 8x, if we factorize this out, we end up with x brackets x plus 8. And if we take x squared plus 10x plus 16, in order to factorize this quadratic, we're going to need to use the AC method. So we need two numbers that multiply to give us 16, but add to give us 10. So if we think of the factors of 16, so we've got 8 and 2 should work. So this one is just simply going to be x plus 8 and x plus 2. Now hopefully you can see that in our numerator we've got x plus 8, and in our denominator we've also got x plus 8, meaning that we can cancel them out. So if we just cancel out the x plus 8, we are left with, quite simply, x over x plus 2. Now in this example we've got simplify fully 2 brackets x plus 7 to the power of 4 over x plus 7 to the power of 3. It looks complicated, but the way you should think about it is x plus 7 to the power of 4 just means x plus 7 times by itself 4 times. So we've got 2 brackets x plus 7, brackets x plus 7, brackets x plus 7, x plus 7. I probably should have just copied and pasted that. And same for the bottom one. It just means x plus 7 multiplied by itself 3 times. Hopefully now you can just see you can cancel some from the numerator and denominator down. So we've got one pair there, another pair there, and finally one more pair. What are we left with? Well, the answer is 2 brackets x plus 7 in the numerator. Another way to think about it, which is probably a better way, even though the first way is better for understanding, is if we had, for example, 2a to the power of 4 over a to the power of 3, well, you can just apply indices laws. So it's just simply 2 and then a to the power of 4 divided by a to the power of 3, which is just a to the power of 4 minus 3, which is a to the power of 1. So 2a to the power of 1 is 2a. A in this case would technically be your x plus 7. So you can just replace a with x plus 7. For understanding's sake, I would probably just stick to the first one, and the second one, if you understand and are good with indices, yeah, I would just stick to the second method. Okay, for some reason, this sort of question always throws off students. They see x squared minus 4 and they lose their heads. Well, if we've got an x squared term, no x term, and then a constant, usually it's a difference of 2 squares. Okay, so x squared is a squared term, 4 is a squared term. So the double bracket is simply x squared square rooted. Oops, let's hide that from you lot. That x squared square rooted, which is x, so put x in both brackets. What's 4 square rooted? So let me do that in a different color. Well, the answer is positive 2 and negative 2. Positive 2 and negative 2. So that's what my numerator will look like. Denominator, same as before. We're finding two numbers that multiply to give me 10, but add to give me negative 7. So the only way I can really make 7 is with the factors 5 and 2. Now, I need a positive number, but they need to add to give me a negative number. So that gives me a clue that both of them must be negative. So my denominator must be x minus 5 and x minus 2. Now, luckily for me, I can cancel out one of the x minus 2's. I'm left with x plus 2 over x minus 5. And I'll just stop there. Let me know if that doesn't make any sense, and I'll try and redo it in the next video. Okay, this is a slightly more complicated example. As I said to you before, if we've got an x squared term, no x term, and then we've got a constant, usually it's a difference of two squares. So if we take the numerator, I'll write it here, the 4x squared minus 25. 4 is a squared term, x squared is a squared term, 25 is a squared term. So what I'm going to do is square root 4, so it's going to be 2 and 2. Square root x squared is going to be x and x. Then I'm going to square root 25, so it's going to be 5 and 5. How do I get the negative in the middle? Well, the only way is if I multiply a positive number by a negative number. That's how I would do difference of two squares. And then I've got 6x squared minus 11x minus 10. Oh, this is going to be long. Okay, so I would use the AC method. I need two numbers, so a times c. So don't know, that's ax squared minus bx, well, plus bx plus c. I need to do a times by c. In this case, is 6 times by negative 10, which is negative 60. Of the negative 60, I need to find factors that are going to add to give me b. B in this case is, I'll just draw it here. Don't know why I'm drawing it so far away. Let me bring that closer. There you go. Okay, so that b is going to be negative 11. So I need two numbers that will multiply to give me negative 60, but add to give me 11. So off the top of my head, so you've got 60 and 1, definitely not. 30 and 2, nope. 15 and 4, so that will get 11 somehow. So let's stick with 15 and 4, so 4 and 15, sorry. How do I make negative 11? Well, the 15 must be negative, makes sense, because 60 has to be negative as well. So I'm going to end up with, let me get rid of this, so you can see. All you're doing with the AC method is you are splitting up the x term. So I'm going to split it up into 6x squared plus 4x, sorry. Then I'm going to minus 15x, and then I'm going to minus 10. I'll make a tutorial on the AC method later. I'm just going through this quite quickly, just so you can see what I'm doing. I'm going to split the 4 terms down the middle. I'm going to factorize 6x squared plus 4x, so I can take out, make sure you're taking out the highest common factor of both, so I can take out 2x. I'm going to be left with 3x plus 2. This 3x plus 2 should repeat on the other side. If it doesn't, you've gone wrong somewhere, so just bear that in mind. So minus 15x minus 10, I can factorize out negative 5. Inside the bracket then, I should have 3x times negative 5 will give me negative 15x, and positive 2 times negative 5 should also give me negative 10. As I said before, the inside the bracket should have repeated. Sorry, I lost my train of thought there. So now I've got 2x minus 5. Oops, let's make it a bit obvious what I'm doing. This 2x and this minus 5, I've written it here. That's one bracket. And then the repeated bracket is the second one, so that's 3x plus 2. Now, at this point, because this is the numerator, I'm just going to bring back my... Sorry, that was the denominator. I'm just going to bring back my numerator, which is this one here. So let's just bring that. Okay, hopefully you can see some of the terms here can cancel now. So 2x plus 5 cannot be cancelled, but 2x minus 5 can, so I'm just going to cancel that down. And okay, so this just becomes 2x plus 5 in the numerator over 3x plus 2. And that's your answer done. Okay, so that was a bit long-winded. If you do want me to make a video on the AC method, please let me know. Thank you for watching. This has been Mr Miah at R Squared Tuition. Don't forget to like and subscribe, turn on notifications, and comment below any questions or topics that you would like me to cover.